28 million. Just let that number sink in for a second. Right now, 28 million people in the US alone are hard of hearing or deaf. It's this massive, massive scale of human experience that honestly often goes completely unseen. But today, we're going to make it visible. And more importantly, we're going to look at exactly how science is fighting back.
Welcome to The Explainer. Today we're taking a seriously fascinating journey into how medical technology can literally restore one of our most fundamental human senses, sound. We're going to look at the evolution, the biological mechanics, and honestly, the mind-blowing future of cochlear implants.
So here's our roadmap for today. We're going to start by mapping out the scope of hearing loss, then we'll look at how we hear naturally. From there, we'll break down the cochlear implant solution, walk through the actual patient journey to getting one, and finally, we're going to peek into the incredible future of hearing tech.
Okay, let's dive right into Section 1, the scope of hearing loss, a widespread challenge.
The stakes here are incredibly high. 50 million people are dealing with tinnitus, that constant, frustrating ringing in the ears. Another 30 million are exposed to hazardous noise levels on a regular basis. And when we look at actual hearing loss, 26 million people are hard of hearing, and 2 million are entirely deaf. Millions of lives are impacted by this every single day, which is exactly why solving this challenge is absolutely critical.
So clinically speaking, hearing loss is classified by the absolute softest sound a person can hear, and that's measured precisely in decibels, or dB. Now, normal hearing falls into that 0 to 25 dB range. But as that threshold increases, we move into mild, moderate, severe, and finally, profound hearing loss, which is basically anything over 85 decibels. When someone reaches those severe to profound categories, standard hearing aids, they usually just aren't enough.
Which brings us to Section 2, how we hear naturally, inside the ear. Because before we can understand how technology fixes hearing, we've got to understand the biological normal.
Let's trace the natural path of a sound. Sound waves enter your ear canal and they hit the eardrum. That vibration then travels through these tiny, tiny bones in the middle ear, the hammer, the anvil, and the stirrup. Those bones push that mechanical vibration right into the inner ear, specifically into a snail-shaped organ called the cochlea. Once inside the cochlea, those physical vibrations are translated into signals that the auditory nerve carries straight up to the brain.
Now, I want you to think of your cochlea like a musical instrument, specifically a piano keyboard. Just like a piano is laid out with low notes on one end and high notes on the other, the cochlea is what we call tonotopically organized. It maps out different frequencies of sound in very specific physical locations. So when the little hair cells in a specific region of this biological keyboard are damaged, you literally lose the ability to hear those specific notes.
So what exactly happens when that natural piano breaks down? Let's move to Section 3, the cochlear implant solution, bridging the gap.
A cochlear implant is an absolute marvel of modern medicine. It's really important to know it isn't just a louder hearing aid. It's actually a surgically implanted device that entirely bypasses the damaged parts of the ear. It has 5 core components, and they're divided into external pieces that sit outside the ear and internal hardware that's placed underneath the skin to directly stimulate the auditory system.
Let's walk through how this whole flow works logically. Step 1. An external microphone captures the acoustic sound. 2. A speech processor translates that sound into digital signals. 3. A transmitter coil sends those signals right across the skin using radio frequencies. 4. The internal receiver picks them up. And 5. This is the real magic right here. An electrode array, which is surgically threaded right into that piano keyboard of the cochlea we talked about, delivers electrical pulses to stimulate the auditory nerve. It literally translates acoustic sound into an electrical language that the brain can process.
Now, getting this incredible piece of hardware isn't just some quick walk-in procedure. Let's look at Section 4, the path to implantation, a patient's journey.
Right off the bat, not everyone with hearing loss qualifies for an implant. The selection criteria are highly specific, and they actually vary a lot by age. For adults, candidates generally have severe to profound bilateral sensory neural hearing loss, which basically means severe nerve damage in both ears, with sentence recognition on standard tests like the HINT test sitting at or below 50%. For infants around 12 to 24 months, doctors are looking for profound loss and a plateau in developing auditory skills. And for older children, word recognition is usually at 30% or less, even with the absolute best hearing aids. The evaluations are extremely